Greetings of peace everyone, Assalamu alaikum. The cascading effect of land degradation, biodiversity loss, climate change, water insecurity, and food system disruption presents the profound pressure on the biophysical systems that sustain human societies. The nature-positive framework provides an important conceptual foundation based on biodiversity conservation of species, ecosystems, and large-scale biotic and abiotic processes contributing to Earth system stability. At the species level, approximately 48% of vertebrate and insect species are declining, while 49% are stable and only 3% are increasing. Species genetic diversity is also being lost at a rate of 6% globally, with substantially higher losses among island species. These trends reduce adaptive capacity and increase vulnerability to environmental change. At the ecosystem level, approximately 54% of the world's ecoregions are severely degraded, while another 25% are experiencing continuing degradation. Only approximately one quarter remain largely intact. Only about 30% of the world's rivers remain free-flowing, while nutrient runoff has produced extensive hypoxic or dead zones in downstream coastal and estuarine environments. The nature-positive framework responds by proposing a global goal to halt and reverse nature loss by 2030 relative to a 2020 baseline, with full recovery of nature envisioned by 2050. The approach complements the Paris Agreement's net zero objective and the Sustainable Development Goals by addressing the biological foundations of Earth system stability. The implication is consequential for UNCCD. The historical trajectory of climate science provide an important starting point. The well-known illustration featuring a traveler reaching beyond the apparent boundary of the Earth, published in 1888 in Camille Flammarion's L'Atmosphère Météorologie Populaire, represented the 19th century effort to understand atmospheric processes through the emerging sciences of meteorology and astronomy. Julia Shepard uses this image in her study Science-State Alliances and Climate Engineering, a longue-durée picture tracing the Earth climate from the late 1950s through the early 21st century. Her analysis shows that climate engineering is not simply the product of recent technological innovation. It has developed through a long relationship between scientific knowledge, state institutions, and political ambitions to predict, manage, and potentially modify atmospheric processes. In Flammarion's period, scientific inquiry sought to understand the atmosphere. Today, science increasingly provides the capacity not only to observe planetary processes, but also to deliberately intervene in them. Carbon dioxide removal may contribute to reducing atmospheric CO2 concentrations. Solar radiation management could theoretically influence radiating forcing, yet neither approach by itself restores species diversity, nor does restore soil fertility of wetlands, rangelands, or their anchored ecological relationships. The nature-positive framework makes this distinction explicit. It argues that preserving remaining intact nature is the most urgent priority because ecological losses and carbon stocks accumulated over centuries cannot necessarily be reconstructed within the time available for climate stabilization. Restoration remains essential in degraded landscapes, but prevention of further ecological loss has greater immediacy. Afforestation or tree planting could not be equated automatically with ecological restoration. The missing dimension is that biodiversity policy has traditionally focused too heavily on patterns and predictive models and insufficiently on processes. We can understand this better through the HIMA system, based on the prophetic teachings of a merciful and protective approach to the grand scheme of the natural world. This approach is still one of the most widespread conservation systems globally. UNEP publication Al-Mizan, A Covenant for the Earth, describes Al-Haramain al-Sharifain, the inviolable sanctuaries in Mecca and Medina, as primordial protected areas, an early model of place-based ecological protection, in which the web of biodiverse species are protected and preserved as communities like yourself, as quoted in the Quran. A recent ecological research in the sacred sites of Mecca recorded species richness increased by 90.9%, with 82% species turnover and 66% of the taxa missing compared to the earlier survey. The authors attributed these changes in floristic composition to afforestation that facilitated invasive and disturbance-tolerant species. This study shows that conservation is not simply a question of how many species remain, but of whether the greater ecological relationships at the planetary scale remain functionally balanced. The three global conditions framework identifies approximately 26% of the terrestrial areas as large wild areas, 55% as shared landscapes, and 18% as cities and farms. The framework is useful because it rejects the idea that one conservation strategy can be applied uniformly. Nature positive is therefore not synonymous with restoration everywhere. It is a differentiated strategy of protection, sustainable management, and restoration according to the ecological condition and the people who inhabit those landscapes. Intact ecosystems frequently occur within or alongside territories managed by indigenous peoples and traditional communities. Their knowledge is derived from sustained observation and interaction with particular ecological contexts that may complement scientific data sets. The authors propose respectful engagement in an ethical space in which knowledge systems can be reconciled rather than placed in a hierarchy. This creates a natural bridge to indigenous and local medical knowledge on biodiversity, cultural heritage, ecological indicators, and sources of community health knowledge. Their conservation, therefore, offers a practical means of connecting biodiversity protection with cultural continuity and planetary health. A genuinely nature-positive approach should consequently seek to restore both ecological function and the human capacity to steward it. The study, Conservation with Local People, Medicinal Plants as Cultural Keystone Species in the Southern Alps, provides a practical example of how this integration can operate. Assessed 273 native medicinal plant species and identified 10 leading candidates for the status of cultural keystone species. The methodology combined ecological information about planet habitats with their significance to local communities. The concept of the cultural keystone species is important because conventional conservation often privileges ecological indicators while overlooking the cultural histories that helped shape landscapes. The findings are especially instructive because medicinal plants were not isolated pharmaceutical resources. They were embedded in wider systems of cultural practice. The plants had medicinal, food, veterinary, cosmetic, household, and spiritual uses. Several species were associated with traditional landscape management. 8 of the 10 leading candidates had medicinal uses supported by pharmacological evidence cited by the authors. This model becomes more significant when viewed through planetary health, particularly in regions where environmental degradation and health vulnerability reinforce one another. Iraq illustrates this interaction with unusual clarity. Abdullah Shihab's 2026 analysis for the Planetary Health Alliance describes a food system under simultaneous pressure from water scarcity, recurrent drought, degraded soils, geopolitical instability, and uneven public investment. Agricultural production has become increasingly vulnerable to water stress and climate uncertainty. Satellite-based assessments indicate that vegetation stress has shifted from an occasional to a recurring national pattern. The problem is not simply insufficient wheat. The Iraqi food system has historically depended upon a more diverse combination of crops, livestock, and locally grounded agricultural knowledge. Increasing concentration around wheat has created strategic advantages for stable security, but also reduced dietary and agricultural diversity. The decline of maize, sesame, vegetables, fodder crops, and mixed farming reduces nutritional and ecological resilience. The planetary health interpretation therefore changes the policy question. The issue is not merely how to produce more wheat, it is how to restore the ecological and social conditions under which a diverse food system can remain viable. Somalia demonstrates what happens when climatic shocks interact with ecological and socio-economic vulnerability. According to the UN's February 2026 reporting, the number of people experiencing acute food insecurity in Somalia had almost doubled to 6.5 million within a year. More than 1.8 million children under 5 were projected to face acute malnutrition through June 2026. The crisis followed failed dare rains, declining food production, conflict, and high food prices. These statistics should not be interpreted simply as evidence of inadequate emergency response. They demonstrate the importance of pre-crisis resilience. Drought becomes catastrophic when agricultural systems, rangelands, water infrastructure, markets, and livelihood have insufficient capacity to absorb climatic variability. Land restoration, therefore, becomes a form of risk reduction. Diversified crops can reduce dependence on a single rainfall window. The objective should be to connect humanitarian preparedness with long-term ecological restoration rather than treating them as separate policy cycles. At this point, the connection between climate engineering and land restoration becomes clearer. The deeper problem is conceptual. It can encourage policymakers to think of climate as an engineering variable that can be adjusted independently of the living systems that make the planet habitable. The nature-positive approach treats humanity as embedded within nature. Such cultural perspectives argue that indigenous and local knowledge must contribute through respectful engagement in an ethical space with empirical science. This is essential if knowledge integration is to avoid becoming another form of resource extraction. The economic dimension is equally important. The Nature Positive paper estimates approximately $7 trillion annually in net nature negative financial flows, including around $5 trillion from private sources. This means that restoration finance alone is insufficient. Financial incentives and economic activities that actively drive degradation must also be transformed. Current commitments cover less than 0.5% of the total estimated 2030 requirement. This is highly relevant to the economic imperative for COP17 action. While the launch of the Riyadh Global Drought Resilience Partnership successfully mobilized 12 billion pool of pledges, the total capital required to address global land degradation, drought, and related restoration needs stands at 2.6 trillion by the end of this decade. This financing deficit is a critical bottleneck in the global environmental sustainability. The historical significance of Flammarion image featuring a traveler looking beyond the apparent boundary of the world can be read as an image of scientific curiosity. A century later, that curiosity has developed into the capacity to observe the Earth at the planetary scale and to deliberately intervene in its climate. The challenge now is to determine what intellectual and institutional framework should guide that capacity. Nature-positive framework argues that Earth system stability depends upon the integrity of the living systems and the nature processes connecting them. The Southern Alps research demonstrates that cultural knowledge and biodiversity can be integrated through the concept of the cultural keystone species. Iraq shows that land, water, agriculture, and health form one food system problem. Somalia demonstrates how drought can rapidly become a humanitarian crisis when ecological and socio-economic resilience are weak. Taken together, these studies suggest a more demanding proposition than conventional restoration. For the Middle East and North Africa, a biocultural restoration strategy is particularly relevant because drought, water scarcity, agricultural vulnerability, land degradation, and biodiversity loss are already interacting with food insecurity and displacement pressures. Iraq and Somalia demonstrate different manifestations of this vulnerability. The strategic opportunity at COP17 is to make land restoration the connective tissue between climate policy, biodiversity policy, and planetary health. Nature Positive provides the ecological direction. Indigenous and local knowledge provide place-based knowledge and stewardship. Planetary health provide the human health rationale. The most important shift is conceptual. Restoration should no longer be understood as repairing what has already been lost. It should be understood as rebuilding the conditions under which biodiversity, ecological processes, knowledge, food systems, and human societies can remain resilient together. Thank you.